discuss about the vector atom model in this unit. But before we start, we should have some basic idea about quantum numbers. Now at the beginning, when the vector atom model came into the picture, before that there was the Bohr model. And as per the Bohr model, the electron will actually revolve around the nucleus in an orbit.
But in reality, when the quantum mechanics picture came in, the electron will not be in an orbit, but in the and only if these electron has got different properties. That means the quantum number associated with, say, these two electrons should be different.
Now what are these quantum numbers that we should know? There are basically 4 quantum numbers that we are going to discuss, and the first is called the principal quantum number. Now the principal quantum number is denoted by n, and if you remember the last unit when we talked about particle in a box, we have found out that the energy that this particle may have, which is trapped inside a box of a dimension maybe of 10 to the power minus 10 meter, is n square pi square h square by 2 ma square. Now this n actually represents the quantum number, principal quantum number rather, and this will actually give you an idea about the electron occupying which energy level. Now this n can take the value from 1, 2, 3 and so on, where 1 will represent the ground state, 2 and 3 will represent the first excited state, the second excited state and so on. Always remember, it doesn't start with 0, because if it's 0, the energy will become 0, which is not possible, because if a particle is trapped inside a box, it will definitely have some energy. The second quantum number that we should know is called the orbital quantum number. The orbital quantum number is denoted by n,
and its value can be starting from 0 and go up to n minus 1. If n is equal to 2, L can take the value as 0 up to n minus 1 means 2 minus 1, which is 1.
and now for 0 it's a spherical shape, but for 1, which actually signifies that the electron is in a higher excited state, the shape would be in this way. So this is basically a double shape. So the electron can be anywhere within this region. So it's simple. If the electron gets to the excited state, the shape changes from sphere to a double. Next. Now we know that if we basically have a charge, and if it is moving, it will basically create some kind of magnetic field. Now the quantum number associated with this magnetic field of the moving electron or a moving charge is called a magnetic orbital quantum number, denoted by ml, and the values that it can take can be minus L, 0 up to plus L. Okay. Let me give an example. If L is 0, ml is 0. That means when L is equal to 0, there is only one possible value of ml. These restrictions on the values that it can have are basically known as the selection rule. Also, we do understand that quantum mechanics give you values which are quantized. You cannot have all the values, only certain values are possible.
So the magnetic quantum number tells me about the potential. the orientation may be like this along the x-axis, and we can denote it as p to the base x. If it is 0, maybe it's along the y-axis, and we can present it along as py. And if it is 1, the orientation may be along the z-axis, and we can write it as pz. So you can see the dumbbell is oriented along the x-axis, y-axis or z-axis, and hence there are 3 possible orientation. You must remember that when we are talking about L is equal to 1, it's dumbbell. When L is equal to 2, the shape will be something different, but right now we are not going to discuss that. Let's restrict ourselves to only this point. The last quantum number that we should actually discuss is called the magnetic quantum number, and let me write it down as this as number 4, and this is called, or rather I will write it down as not the magnetic, sorry, the spin quantum number, right? So we'll write it down as the spin quantum number. Now the electrons which are revolving around the nucleus will also have a spin around its own axis. This is very important. We have the nucleus and the electrons are moving in certain orbital, but the electron which is revolving around the nucleus will also have a spin of its own around its own axis. Now the spin may be in this direction, maybe in the anti-clockwise direction, or maybe in the clockwise direction. So based on this, we are basically going to have another quantum number which is called the spin quantum number, also called as the magnetic spin quantum number, and this will give you the value of the spin that it can have. Now you know spin can be either plus half or minus half. If you're basically considering an electron is a half spin particle, we basically call it as the fermion. So we also say when it's having an up spin plus half, or it might have a down spin minus half. So if you are having 2 electrons, they will be having 4 quantum numbers associated with each of them. One is L, one is L, ms, and ml. So might be n, l, and ml are same, and ms might be plus half and minus half, and this will differentiate the 2 electrons, and they can occupy the same quantum level. So that's it for the quantum numbers that we have in the vector atom model.